Okay, so welcome back. Today we are going to solve some numericals based on electric field. So today our topic is electric field due to system of charges. But let us understand first one important principle on which all the numericals will be based, and this principle is known as superposition principle. Okay, so the statement says that electrostatic force, because it is valid for all the vector quantities. So we are not just limiting our discussion to field, it can be force also. So electric force experienced by a charge due to other charges is the vector sum of electrostatic forces due to these other charges as if they are existing individually. Okay, so this is a statement. It may be possible that the statement is not too much clear. So let us take one important example and solve this numerical. So in this numerical, as you can see here, we are having one source charge here, that is capital Q. So this is your source charge here. Okay, and this source charge, and we are having two neighboring charges, one is Q1 and another is Q2. So Q1 has the value of minus 10 to the power minus 8 coulombs. Okay, this is minus sign here, blue sign is minus sign here, this is, and this is Q2 plus 10 to the minus 8 coulomb. Okay, so coulomb is the unit of charge. So we are having one more charge here, one is here and one is here. So this is your negative charge while this is your positive charge. And we have to calculate net electric field on this value. What is the net electric field on this value? So let us see one by one. Okay, now first of all we see the logical explanation for this. Okay, so as you can see here that this negative charge, as you can see on the screen, this negative charge will actually try to pull the positive charge towards its side, because negative will attract the positive. So basically the electric field will be like this. Okay, so we can see the direction of electric field will be like this. Now this here plus charge and this is also plus charge, so plus and plus will repel each other. So basically it will repel the source charge. So basically electric field direction will be like this. So again you can see both the charges are actually applying the net electric field towards the left side. Okay, so basically their magnitude will add up. Okay, so magnitude we have to find between the positive charge and the source charge and the magnitude of first charge on the source charge. So let us calculate it one by one. Okay, so first of all we will calculate the magnitude due to the Q1 charge on the source charge. Okay, so in this question we are going to apply this formula here. E is equal to kq upon r square. So k is constant and the value of k is written here 9 into 10 power 9. So we will substitute the value here only, and this q, it can be q1 and it can be q2 depending upon the conditions, and r is the distance. As you can see, the distance between source q and q1 is 1 meter, and source q and q2 is also 1 meter. So we have got the distance. Now we will apply one by one. So first of all, and we are writing here eq1, that is q is your source and 1 is due to the first charge. V means electric field on q due to the first charge. So that is k, this is the value of q, that is 10 to the minus 8. We are not taking this sign because it is for representing the direction, that we will talk later on. And r square, r is the distance here and r is how much? 1 meter. So I'm putting the value of 1. Okay, and we can write here 1 square also. So this is 1 square. So basically it is equal to, value of k is 9 into 10 to the power 9 into 10 to the power minus 8, and that is 1, because 1 square is 1 only. So 10 to the power 9 and 10 to the power minus 8. So that will give you, 10 to the power 9 plus 9 and minus 8 will give you only plus 1 here. So that is 10 only. So 9 into 10 is equal to your first answer, that is 90 Newton per coulomb, because of this one, that is your Q1 on Q. We're going to find the value of electric field on the same charge, that is Q, but due to the Q2. So again we will apply the same formula here, but we will change the values here. Electric field on the same charge, on this charge only, we are finding because of Q2. So that will give you the equation k into 10 to the power minus 8 upon 1 square. Distance is again 1 and charge is here, that is 10 to the minus 8 coulombs. Okay, so this will be equal to same value, that is 9 into 10 to the power 9 So that will be equal to the same value, 9 into 10 to the power 9 into 10 to the power minus 8, and which will be equal to, so 9 into 10 is 90 Newton per Coulomb. So we have got the two values here. As you can see that this is your first, this is your first value and this is your second value. Now on the same charge we are having two effects, one of Q1 and another of Q2. So finally we have to apply the superposition principle. So we can write here, okay, so net electric field is equal to, as you can see here, it is equal to EQ1 plus EQ2. So we are going to add both these values, and 90 plus 90, that is equal to 180 Newton per Coulomb. So this is your final answer. Charge, it will experience an electric field of 180 Newton per Coulomb, and this is the direction towards the, we can say, towards left side. Okay, so I have one more question, and in this question we have changed the values. Like you can see here, this is our source charge. As you can see here, our source charge is placed at this point. So our source charge is this now, okay, which is kept at one of the corners, and this is your test charge Q1 and this is your test charge Q2. This is positive while this is your negative. Okay, so now logically let us find the answer first, then we will solve it numerically. So logically, what logic says, that this positive charge, this Q1, will try to attract this Q, okay, with more force. So basically it will attract like this. Okay, so this will move towards Q1, but at the same time Q2 will try to oppose this source charge, okay, but in the opposite direction. So basically this will apply a repulsive force. So we can say a weak repulsive force. Okay, so Q2 will repel Q like this. Okay, this is repulsion, and okay, so we can say that this second charge Q2 will try to repel this, okay, but with a weak force. So we can draw a line here, and so we can show a little bit weak, but as you can see that this is more and the second one is less. So this is like very less. So what will be the net effect? Where does this source charge will go? Answer is towards right. That means Q1 will have more effect than the Q2 on the source charge. So net field, or we can say the direction of electric field towards right side. Okay, so as you can see here, we are having the values here. So we are going to find the net field on Q. Okay, so you can see here that Q1 is here. So first of all we are going to find the effect on Q. So formula is same only, E is equal to KQ upon R square. So on Q, due to 1, so we can write here minus 9 into 10 to the power 9 into 10 to the power minus 8 upon 1 square. We can write the minus sign. Why? Because we are going to net effect here, because we are going to find the net effect here, as green has more effect than the red one. So what we are going to do is that we are going to cancel out the effect of red from the green one. Okay, so we are putting the subtraction sign here, as this is a minus charge. In the previous question, minus and plus both were actually attracting on the same side, but in this case green is attracting towards the right side while the positive is repelling towards the opposite side. So we have to cancel here, minus sign is used, that is the reason. Okay, so now due to the second one, you can see same values, 9 into 10 to the power 9 into 10 to the power minus 8 upon 2. 2 is the distance from the source charge, so 2 square. So solving it further, we will get the values. Okay, so as you can see here, the values of we have written here. So this is your answer for the first one, minus 90 Newton per Coulomb, and by solving the second equation you will get the answer 2.25 Newton per Coulomb. Okay, now we have to find the most interesting part, that is the net electric field, and which is equal to okay, so here we are having now values. Net electric field is equal to EQ1 plus EQ2, you can see here, and by putting the values of these we get minus 90 plus 2.25. So the final answer comes out to be 87.75 Newton per Coulomb is the unit, and the net field will be like this. So this will be the direction of net field, that is towards the right side. So direction will be towards the right side of net electric field. I hope these both examples are clear to you, and There are some more examples which you can solve from NCERT books that we will discuss in the later sections. So see you in next class.